Hello everyone, good morning. My name is Donia Malekian and I'm a PhD student in computer science. And today I'll be presenting my joint work with my PhD supervisors James Bailey and Gregor Kennedy. Our research is about predicting a student's assessment readiness in online learning environments and also showing that the sequential dimension in modeling a student's behavior is important to be considered. I would begin with the motivation of this research, then a general introduction, kind of some background to where this research comes from. After that, I'll talk about the objective of the study and then our approach and the discussion around it. And lastly, I'll summarize the research. Online learning environments are now pervasive in higher education, and although there are many advantages of these environments, the scale of them present educators with challenges such as providing the necessary supervision to students. And in this environment, students are often solitary learners and their success relies more heavily on their abilities in self-directed learning. In these environments, open learning structure are often emphasized in which students are offered unlimited access to different instructional materials such as video, lecture, and assessment materials. And these unlimited offer make these environments more challenging for students. In this context, students may access, in particular, assessment material without being fully prepared. And these assessment tasks often form an important component of learning environment because they allow students to reflect on their own level of learning. And there are many research that show that when students are unsuccessful in assessments, this can have a negative impact on their confidence in their ability to succeed, which can lead to their disengagement. And this argument has been also examined and confirmed in MOOC studies as well. Therefore, monitoring and predicting a student's performance on assessment tasks could provide an opportunity for developing adaptive environments aware of a student's progress and potentially delay or postpone tasks in case the students are not ready. Also, a deeper understanding of a student's behavior before completing an assessment and knowing whether this behavior is different for students with high or low level of achievement can be used to consider support and intervention that could increase the student's success. Many studies in online learning have focused on modeling different aspects of a student's learning behavior in online courses with the aim of usually predicting their final performance or dropout or understanding their various behavior. And in modeling and understanding learners' behavior, it is important to consider different levels of data available and the level at which the activities are structured. So based on the research, as you can see, data can be analyzed at various levels, such as task, session, or course, and it can be represented at different levels of granularities, such as the students' interactions or student sessions and activities on broader levels like course or student. Research shows that many effort has been made by use of learning analytics to examine aggregated and frequency measure of a student's action and activities, usually at the course level, such as, for instance, number of sessions, number of video watch, or access to discussion forum. However, a sequential representation of a student's learning behavior toward a specific task might be more useful in showing how the process of a student's learning over time impacts on other key learning processes and outcomes. So, for instance, in this slide, you can see two students with the same activities, but the activities are ordered in different ways. The aggregated representation of the activities for these students is equal. However, the sequential representation might reveal more information about the process. For instance, the first student reviewed, so after failure, reviewed the material and then failed again, then asked for help and became successful. However, the second one applied some strategies, then failed, and then without doing any strategy, submitted an assessment again, and then again failed. So in here, the sequential representation of behavior could better reveal the student's progress. Also, examining a student's behavior toward completing an assessment task could better reveal the student's progress rather than analyzing it across the overall course. In particular, in this research, we define and answer 3 research questions. The first one is that can useful prediction models be developed for predicting a student's assessment result? And does it matter if the sequential nature of a student's activities is considered in the model rather than aggregated measures? The second research question is that what is the impact of considering the most recent activities prior to submission in the models compared to considering more historical activities by students? And the last one is examining to see if there are differences in assessment preparation behavior of students that could lead to high or low level of performance in assessment. To answer our research question, we conducted our analysis on 2 offerings of the MOOCs. MOOC called Discrete Optimization, provided by the University of Melbourne. You can see the summary of these MOOCs in the table. In the first offering of the course of around 51,000 students who initially enrolled around 6,600, approximately 12% engaged in the assessment. From those 2,600, around 39% dropped out of the course immediately after a failure in an assessment. Of course, we cannot be sure about the reasons for disengagement, but one possible explanation is that failure experiences influence some students to doubt their abilities to succeed, which then resulted in their disengagement. And also in this course, students were permitted to make an unlimited number of submissions for each assessment. And as we can see in the plots in both offerings, we can see that most of the submissions for each assessment were unsuccessful except for the first assessment, which were considered to be an easy task. So to answer our first question, which we aim to examine if we can predict a student's assessment result, we focus on a students' learning activities that help students achieve course outcome and reflect particular kinds of approaches to online study. The activities that we considered involved accessing and downloading the lecture, re-accessing and re-downloading the previously accessed lecture, and accessing discussion forum and submitting assessment. So you can see a sample representation of these activities for students in this slide. We built 2 profiles for students, one based on aggregated and the other one based on the sequences of the same learning activities. So the aggregated profile, in the aggregated profile, each submission was described by a D-dimensional vector of features, as you can see, which was based on students' activities started from the beginning of the course and ended before that submission. And in the sequential profile, each submission was described by a variable sequence of the order activities, again similar to the aggregated one, conducted by students who started from the beginning of the course and ended before that submission. So for the sequential one, you can see an example for the sample students that you can see in the figure. So once we developed the profile, the effectiveness of the profiles were examined using machine learning classifiers. So the effectiveness of the sequential profile was evaluated using a sequential machine learning classifier called LSTM, and the effectiveness of the aggregated profile was evaluating using multi-layer perceptron. The class label for this prediction was the final result of an assessment. Was the result of a submission for an assessment, and for each assessment, the students needed a mark of at least 70% to pass. So the pass mark was considered to be 70% of the total score. We use the first offering of the MOOC to train the model and the second offering as a test set to evaluate our models. We also investigated the utility of the aggregated profile based on a baseline model of logistic regression to make sure the result we obtained using MLP was not misspecified. As you can see in the table, we found the sequential profile outperformed the aggregated one, which shows the importance of the sequential representation of a student's behavior. And the reason that we utilized neural network models for the evaluation purpose was that these models are popular for learning complex relationship from data, which we think that it's the case for a student's learning behavior. And their effectiveness has been also confirmed in few learning analytics research for predicting a student's final performance compared to like simple linear models. Having these models, in the second research question, we examined whether building our models based on the various number of recent activities before submission would make any difference in their prediction power of assessment outcome. So the figure shows the performance of the models considering various number of recent activities prior to submission. The x-axis corresponds to the upper limit on the number of activities, and the y-axis is the model's performance. And as you can see, all algorithms work better when considering more activities, and this could mean that the overall processes the students applied through the course had more impact on the assessment outcome rather than only the recent activities prior to submission. Also, LSTM worked better than MLP in almost all the cases, which again shows the importance of the sequential representation of the data. So, and the last step was to examine whether there exist differences between the assessment preparation of successful or unsuccessful students in assessments. We use a sequential pattern mining approach using engram extraction and found several sequences of behavior associated with the student's achievement. The top 10 significant patterns which we identified across each of the failed and passed groups of sequences for each offering are represented in the form of a state transition diagram that I'll explain them shortly. We compared the influential patterns between the two MOOCs to see if they are similar in terms of influential patterns. And for this purpose, we use the Spearman rank order correlation. And the results of our analysis showed a strong positive correlation between the rank of significant patterns of the two MOOCs. That could mean the two MOOCs shared similar influential pattern, which is interesting. And so coming back to the interpretation of the influential patterns and the diagram, briefly the results suggested that in the past groups, viewing and reviewing the lecture content for both offering was an important factor for success, which is not surprising. Reviewing behavior could reflect the importance of rehearsal strategy in online learning, which deals with storing information to be learned through various ways. And this result is also consistent with educational findings. So reviewing strategies was found to be important in a student success. On the other side, for the failed group of patterns, an interesting insight is that a considerable number of students tried to improve their performance by attempting the assessment multiple times without doing any activity in between their attempts. That resulted in low performance in all their submission. This pattern could reflect lack of knowledge or effort regulation strategy. Effort regulation has found to be beneficial for learners in handling the failure and setbacks in their learning process by investing and allocating appropriate effort and resource for the better learning in future. And this may imply that simply making multiple submissions without applying any effort and clear strategy does not lead to success in online learning. Also the results confirms educational findings that too many consecutive errors undermine a student's learning performance. So overall, we found it was possible to predict a student's readiness for assessment tasks based on modeling their activities within a MOOC. We also found the sequential dimension in modeling a student's behavior to be important, and there may be a need to account for it in learning analytics research. And the overall process is important to be taken into account too, rather than only the recent activities before submitting a task. And the patterns that we discovered suggest there were several behaviors which impacted on the student's performance, like reviewing the learned content and multiple consecutive failed attempts without doing any clear strategy. So this analysis can be used to monitor a student's progress and readiness over time to delay or postpone tasks that the students are not yet ready for. The patterns can also be considered as a valuable source of information to better understand the student's behavior before completing assessment tasks and can be used to inform educators about the behaviors in need of support. Moreover, adaptive environments could be designed to steer students away from such behavior, for instance, by placing a time constraint between successive attempts or limiting the possible number of attempts on an assessment. However, this study has limitations which can be commonly found in most MOOC studies. The first limitation is related to the generalizability of the analysis and interpretation of the patterns. So this study was based on different offerings of a MOOC, and considering other MOOCs with different learning design could also provide better insight into student assessment preparation behavior and its impact on performance. And the other limitation is that the MOOC that we consider and that was the focus of our study was an optimization course, and the assessments required applied activities that expected the students to put effort to achieve a good outcome. And it might not be as effective for other assessment types, such as when students are able to play with the system or guess the answer without effort. And another limitation is not examining the learner's personal factors such as skills, prior knowledge, demographic factors, their motivation, and many other things throughout the course, as it was beyond the scope of this study, but definitely they could have impact on the students' performance. Yeah. Thank you so much, everyone, for listening.